Hello everyone, welcome to my channel NCRT Mathematics Learning Hub. In this video, I am going to discuss with you all how to check if the 3 points are given to you are collinear or not. We are also going to discuss how to check if the 3 points given to you are forming an isosceles triangle or not. This is the third question of exercise 7.1 of the chapter Coordinate Geometry from NCRT Mathematics textbook. The question says, determine if the 3 points they have given it to you here are collinear. So we need to check these points are collinear or not. I have drawn a line here and I have marked the 3 points on that, A, B and C. And these are the 3 points, so I have taken the coordinate from the question. I have just written it over here. Okay, so if the 3 points are collinear, then AC will be equals to AB plus BC, right? So the total distance AC will be always equal to the sum of the two smaller distance here, AB plus BC, right? So we need to prove that. So for that, let us use the distance formula to find the distance between AC. Then we will sum up the distance between AB and BC to check it is equal or not. So first let us find out AB. Let us write the distance formula. x2 minus x1 the whole square plus y2 minus y1 the whole square, and this is the part AB, line AB that I have just written it here. So what are the coordinate for A? 1, 5. What is the coordinate for B? It is 2, 3, right? So this is x1 y1, this is x2 y2, right? So let us substitute it here. x2 is 2 minus x1 is 1, so it is 2 minus 1 whole square. Then we have 3 minus 5 whole square, right? Substitute the values very carefully, observing which is x1, x2, which is y1, y2. 2 minus 1 will be 1 square plus 3 minus 5. So 1 is positive, 1 is negative. You need to subtract and you need to write the bigger number sign. So 5 minus 3 is 2 and bigger number sign is minus. So minus 2 whole square, right? Then we have here 1 square is 1. Minus 2 into minus 2. Minus 2 square is nothing but minus 2 into minus 2, which is equals to plus 4, right? So let me just write here. So what is the value you have got? Root 5. So now let us find BC. So again you need to write the formula, that is nothing but x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So right here the coordinate of B and C. B is 2, 3 and C is, in the question it is minus 2 and minus 11. Okay, so here also just change it to minus 2 and minus 11. So what are the coordinate of C? It is minus 2 and minus 11. Let's just write what is x1, y1, then x2 and y2, right? Substitute in the formula. What are you going to get? x2 is minus 2 minus of this minus 2 and whole square, this is plus y2 is minus 11 minus this 3, right? Then how much you are going to get? Minus 2 minus 4, minus 2 is nothing but minus 4 whole square plus minus 11 and minus 3 is nothing but minus 14, right? So how much you are going to get? 4 square is nothing but 16. Minus and minus it will get cancelled. You will be getting plus. Then 14 square is nothing but 196. So add these two. How much you are going to get? You are going to get square root of 212. So let us now find AC. AC, for that also just write the distance formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. Now write the line AC or coordinate also you need to mention it here, 1 comma 5, and here minus 2 comma minus 11, right? So just mention that x2 is minus 2 minus 1, it is 1 square plus minus 11 minus 5, which is equals to, you will be getting in the next step, right? Minus 2 and minus 1 both are having negative sign, so it is minus 3, right? Minus 3 square plus minus 11 and minus 5, how much do you get? Minus 16, right? So minus 3 square is nothing but minus 3 into minus 3, which is equals to 9, plus 16 square. 16 square, just calculate it and you will be getting 256. And you need to add 9 to that. So how much you are going to get after adding? 265. Okay. So you can observe that the condition that we have written here, AC, which is equals to AB plus BC, it is not getting satisfied. How do we know that? We have AB here, we have BC here. So if we are going to add these two, we should get root 265, but here these two are the unlike sides, right? So we cannot add these two, so because of that this condition is not getting satisfied. And here you can observe, this is just the assumption that I have taken A, B and C point like this. But if I am taking if I am shuffling these points, because it is just we need to find all the possible outcomes, right? So if I am shifting here A and here B at the end and C is at the center, so what will be the condition? Total length of the line is AB here, so AB should be equals to sum of the smaller two parts, right? So AC plus BC. So let us check this condition also now. So AB is root 5, and if I am going to add these two, I should get AB. So again you can observe these two are unlike terms. If we cannot add these two, and we will never get root 5. So this is also not getting satisfied. Now there is another condition when we have kept B and C at the corner and A is at the middle. So this condition also let us check. Total length is here BC. So BC should be equal to sum of the other two small parts, that is AB plus AC. Right. Now let us check AB plus AC. So AB is root 5 and AC is root 265. We cannot add this, and anyways it is not going to be equal with root of 212. So this condition is also not getting satisfied. Therefore these points are not collinear. The points are not collinear. Okay. So this is how you will find whether the points are collinear or not. So let us now solve the fourth problem of exercise 7.1. The problem says check whether these 3 points are the vertices of the isosceles triangle. So we need to check is the 3 points are forming an isosceles triangle or not. What do you mean by vertices? It is the plural form of vertex. So what is vertex? It is the point. So here we have 3 vertices A, B and C, and I have written the coordinate of the 3 vertex as well. What is isosceles triangle? Isosceles triangle is a triangle in which we have any two sides equal, right? So we will just check in this triangle, are we getting any two sides equal or not? If we are getting, it is forming an isosceles triangle. If we are not getting, then it is not forming an isosceles triangle. So let us write the distance formula to find the distance between the line AB. So let me draw a line AB. I am writing the coordinates of line AB, 5, minus 2, and here we have 6, 4. Right, so write the distance formula for AB line. We have square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? So what is x1 y1? If I am taking this one x1 y1 and this one x2 y2, you can take by changing it also, you are going to get the same answer, because it is the square, and the square of a positive number as well as the negative number, you will be always having positive, right? So we can just substitute it over here. X2 is 6, 6 minus 5 whole square plus 4 minus this is formula minus, and you can observe it is minus 2, so you will write in bracket that minus 2, and again you need to close one more bracket for this one, it is square here. So 6 minus 5, it is nothing but 1 square, plus you can observe minus and minus is there, so minus into minus plus 2 here, 1 square, right? So what are you going to get? 1 plus 4 plus 2 is how much? 6. 6 square, right? So 1 plus 6 square means 36. So you are going to get here root of 37. So let me just draw a line BC. What is the coordinate of B? It is 6, 4. What is the coordinate of C? It is 7, minus 2. Again you need to write the distance formula for line BC. Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So x1 y1, x2 y2. So just substitute now here. 7 minus 6 the whole square plus you have a y2 minus 2 minus this 4, right? So you got minus 2 minus 4 the whole square. So 7 minus 6 is how much? It is 1 square, plus both are having negative sign, so what will you do? You will add it and write the bigger number sign. So it is nothing but minus 6 square, right? Now 1 square is 1, minus 6 square, minus 6 into minus 6, how much do you get? Minus into minus plus 6 6 are 36. So you will write here 36. So you got here square root of 37. So let us draw a line here, and then we will just find out AC, which is remaining part. So I am writing the coordinate of A 5, minus 2. Then here we have C, the coordinate of C is 7, minus 2, right? So let it be x1 y1, this one x2 y2, right? Now we'll find out AC. AC is equals to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So x2 value is 7, 7 minus 5 the whole square plus then we have minus 2 minus, and this is formula minus, and you can observe here the coordinate is also minus 2, so write in double bracket this one, right? 7 minus 5 is 2 square plus here you can observe minus 2, minus into minus it will become plus 2 whole square, right? So how much are you going to get? You are going to get 4, and this one minus 2 and plus 2 will become 0, so plus 0. So square root of 4, which is equals to 2. So for isosceles triangle, any two sides should be equal. So you can observe AB and BC. What is the answer you have got? You have got root of 37, right? So AB is equals to BC. The two sides are equal. Therefore, it is an isosceles triangle. That's it for today's class. In the next video, we will be solving a very interesting question where we will be getting how to get the coordinates from the question, and then we will be finding if it is forming the square or rectangle or any other shape. And please don't forget to like, share, subscribe and press the bell icon.